me put on the record mode. Now I need to record it, right? And later on, I'll post it on YouTube. Right? I'll share the link to you, Dr. Deshinta. Okay, and everybody. Good afternoon, everybody. Good day to you, right? This is week 4, right? Week 4 IDP. So we like to welcome Dr. Deshinta Arrova Dewi from INTI University, from the Faculty of IT, Faculty IT. So today, Dr. Deshinta will give us the idea on this, his expertise, right, and sharing of her experience, right. Before that, let me introduce her. Dr. Deshinta Arrova Dewi, right? She's graduated from National University of Malaysia, right? And now work as the senior lecturer in INTI International University, Nilai, Malaysia. Okay, so her area of expertise will be on software engineering, artificial intelligence, Internet of Things, and data science and machine learning. Right, all these things are very interesting, right, and have good potential in this current era. So she have a patent, right? She has a patent, and then her current activity in INTI University would be the research cluster leaders, right, in handling artificial intelligence and IoT research, right, and others management positions, and also as the editor for the Journal of Data Science, right? So she also received a couple, many actually, right? Many of awards since 2016 to 2022. The recent one would be the Gold Award in International Science and Social Science Innovation Competition, Malaysia, right? And so far, you could find Dr. Deshinta over a number of internet resources, right? Such as LinkedIn, Scopus, ResearchGate, and Scholar Google, right? You can find me as well from the same link, right? I think let's listen to Dr. Deshinta. Now the stage is yours, Dr. Deshinta.
Thank you, Dr. T.
Yeah.
Bismillahirrahmanirrahim. Assalamualaikum and good afternoon to all the participants for this webinar. My name is Dr. Deshinta, and I'm from INTI International University, as has been introduced by Dr. T just now. It is really my privilege to be here, and it is my honor to be able to have sharing session with you all. And today I would like to share the current trend that happening in industry, which is the research still going on, and the number of papers.
Dr. Deshinta, do you want to put what I call enlarge the screen? No,
okay. Yes.
Post into slide.
Like this?
Yeah, that's good, right?
Okay, that's great. So it is my privilege for today to be able to share with you a couple of things in the artificial intelligence and also industry oriented. I understand that the background of the participants for today is from engineering, and I believe you have also a background in IT. So for today, I would like to share about the route optimization problem, and I'm very direct to the point for my delivery for today. The outline for my presentation, first, I would like to share with you regarding the on-demand delivery services that nowadays in the business, everything is about how to bring the product or services right to the customer at hand during its stipulated time, during the stipulated time or preferred time requested by the customer. So I would like to bring you there first about on-demand delivery services. Then after that, we are going to check, or we are going to see what are the solutions that is provided by the artificial intelligence algorithm in order to settle the problems that currently happen in industry. Of course, when we talk about solutions, we can come up with many ideas, And this is where we are referring to the several papers. So conference papers or journal papers, that will be a great platform for us to know the current demand or the current research, or what are the latest technology that has been observed, has been doing some experiments, and then whether this research can be brought as solution for the industry. Maybe we have known that a couple of comments telling us that there are certain gaps, or the gaps are there between university and industry, and this is where the graduates coming from university, some, maybe what I can say is maybe some of the graduates maybe have a little bit challenge or difficulties to understand what really a problem in industry is. And this is where I would like to, for the today's session, I would like to share with you one of the point that maybe we are in the university, you can have some experiments, and then you can explore a lot of technology and also explore a lot of potential solutions once we understand the problems that currently happen in industry. So regarding the solution, I would like to focus on the two things, which is the load planning and also route optimization. So when we talk about the load planning and the route optimization, we involving certain algorithm. We are going to use computer to understand the problem. Then we are going to automate the problem, and this is where certain problems can be solved in a very fast computation process. So as you can see in this picture is basically what's going on, or this is the demand that happening for our customers. So if we position ourselves that we have some product or some services and we like to sell the services or the product, the main concern is that how to make sure that within less than 24 hours, for example, our product or services can reach the customer, as fast as possible, as convenient as possible. And then some customer may have some requests that they would like to receive their parcel or their product within certain time. And this is what artificial intelligence try to solve. So in any occasions, in any occasion in life has become the main trigger for the industry. We talk about anniversary, we talk about birthday, we talk about engagement, we talk about wedding, many parties, many celebration. When we have one occasion, definitely behind there is a business, there is a problem that need to be solved. And this is why in this session I would like to bring some real case study so that the students and all participants here are able to contribute about the solution, what we can provide for the solution from our expertise, which is in this view is from the data science perspective, from the AI perspective, and also from the computer science perspective. Now, let us go for the on-demand delivery services. So, as we know, the customers' demand for the outstanding delivery experiences has been growing, and it has been higher than ever. And then why it's happening? Because more people are buying online. It's very convenient process. And then it's very mobile process whereby a customer can place order anywhere, and then they can request the pickup point, or they can request for delivery point at their convenience in between their preferred time. So this is why the convenient process has made the people the transaction online are becoming more and more. So consequently, in the industry, customer, of course, they expect for the smooth and quick package delivery, and also it is essential for a package delivery process when we are working in that industry. In terms of the growth on demand for the delivery services, the study shows that 80% of the customer expect to be able to track the delivery in real time. So definitely it requires some process behind how we are able to reach our customer, and we can provide a mechanism in a way that customer can track their product or their services that they requested in real time. And then there has been a growing demand as well, around 40% for the customer expect delivery window or 2 hours or less. So meaning that the customer may have an option in which day and which time they prefer to receive the parcel. And we can imagine if we are at this industry, so we have to manage a lot of parcel, we have to manage a lot of requests, and this is where the delivery windows, they usually in between 24 hours, we can promise to the customer that the product will be in hand in the customer location. But now 45%, the study reveals that the 24 hours demand has been lesser and lesser. So this is where in terms of artificial intelligence, we have to create a mechanism, we have to make some process to be intelligent enough to manage all the requests coming from the customer. And this is definitely a challenge. If we can manage 1,000 requests with the different hours and also different day, different time. And in the meantime, we have several resources in our company. So how we are going to manage the resources? So definitely manual process is not an option at all, because the customer would like to have their product in hand in very fast way. So this is where we are relying the process to the artificial intelligence algorithm to help us to identify and also to make the cost efficient in order to ensure that 100% package can be delivered time and at the customer preferred time. So as a result, the business has to be forced somehow to change their operate with and to accommodate and also to adjust or customize to the market mindset. Now, the on-demand delivery services has been seen as the modern logistic strategy. And this is where delivery tracking it become the key component for the modern logistics strategy. So somehow, if we have product and we have services whereby the product need to be transported, so this is where we are looking at the tracking tools and also tracking mechanism to ensure that the transportation tracking tools can gain real-time visibility for the movement, for the fleet movement. So where is it actually the location of the parcel, and then how it has been moving and so on. So that becoming the demand from the customer. And then from the business perspective, on-demand delivery tracking somehow will enable logistics stakeholders to know the shipment in real time. So they want to know exactly what time they can receive this parcel, and also the exact ETA, estimated time arrival, and whether the delivery will be delayed, whether the shipment destination has been shifted, or what about the route diversion. Sometimes when we transport the parcel from one location to another location, somehow we have some challenges in the on the road. For example, we have some traffic jams, or we have some accidents going on, or we have route redirected in a different way. So this is where a customer would like to know what happened with their product, or what happened with the services, or maybe the product in the form of document, which is very important. We talk about IC, we talk about passport, we talk about several confidential documents that may be transported using some delivery services. So this is where we have to be very transparent about where's the document and how we can communicate with the customer on the progress for the delivery, the shipment. And then on-demand delivery also help the customer to gain the live insights into delivery processes. And then through automated, through the automated alerts and also notification, customers are constantly informed whether the orders are there and then where is it until they can reach the customer in time. Okay, I just check on the chatting. So in the chatting here, can I confirm whether you can hear my voice? Because just now I read some chatting and then he says that cannot hear anything. Are you able to hear me now? From Omran. Hi Omran, are you able to hear me now? Okay, that's great. All right. So let me continue. So, so this is what I have discussed, and then the next slide. This is what I mentioned about the modern logistics strategy, and this is if we see the opportunity, what we can do as a researcher, as students at the moment. Maybe some of you are students, or you have some project that you would like to do, and this is where some opportunities are there for us to contribute to the industry. So for example, based on the survey in the delivery services industry, so we have 25%, yeah, which is constitute to the delivery efficiency. So this is where the opportunity for to improve cost in terms of delivery efficiency. This is where we can contribute. Then after that, 14% it is allocated for the margins, 40% are on the customer demand, and then we have delivery agility, and also we have cost, and then we have end customer interaction. We have missed delivery around 8% and 5% for others. So we can see that from this percentage, delivery efficiency has been gained some insights, has become a focus. Okay? I mean, the challenges mainly coming from the efficiency of the delivery services and the product. Now, if the company, yeah, or the shipment industry would like to look at this real problem, this real on-demand delivery services, then they can have immediate benefit for the enterprise. So firstly, it's about larger customer base, yeah, because basically when we transport some product, we can utilize the land transport, we can utilize the air transport, we can utilize so many vehicles or mechanism or technique so that we can reach the larger customer base. And then with the efficiency, definitely we can provide some competitive pricings. And also from the data that we collect, if we make sure that all the data can be monitored lively, so basically we are able to understand and we can get sufficient data to understand about the customer behavior and also the demand pattern. And then efficiency can boost the customer loyalty as well, because the trust level has been there, that their document that are very important for their special occasions has been delivered in time and has been delivered safely. So this is where the trust level will contribute to the loyalty of the customer. And also in terms of infrastructure costs, we can eliminate, we can see that how this is possible to achieve in terms of infrastructure costs. Basically, artificial intelligence will help us to identify how much resources that we can use for our demand on that day. And also we can reduce manual dependency. Definitely manual operation is not an option when we have larger demands, as we can see just now. And also we can have some options to provide self-delivery models, yeah, to make sure that the service and also the product reach the customer in hand. So now let us understand the real case study in here. So on-demand delivery services, what we can see on the surveys is we can have a scenario whereby a consumer, for example, using a mobile app to buy the latest version of iPhone, so just say iPhone 10 or iPhone 13. Yeah? So it is a surprise, for example, birthday gift for his friend. And then what happened, as the birthday in the following day, the consumer needs the phone right away. And then when the consumer places an order, definitely what the consumer see is the application. So this is where the application can trigger the alert. Yeah, this alert will notify the warehouse. So we can see one mechanism has been brought in this view that once the customer places an order, the warehouse must stand by because the kind of product, the type of product must be available. Otherwise, it's not supposed to be appear on the application itself. So once in the application, the product is there, meaning that the product actually available in the warehouse. So we talk about when mechanism notification and also alert from here, which is triggered from the customer when they place an order. Then after that, after the warehouse receiving the notification, so this is where the warehouse will quickly identify the item and forward it for shipping, because we talk about the 24 hours delivery. So we can name a few delivery services that we know. For example, we can have Grab, we can have Lala Move, we can have whatever it is, whatever platform that can reach the customer. The customer basically bring the business C2C, customer to customer. Yeah? And this is where the warehouse quickly identify the item and forward for shipping. And then a driver is immediately assigned. So basically just one click from the customer, you can see that there are many things happen behind the scene. So this is what in IT we call it like back-end processing. So we have front end, which is the application, but then we have also back-end process as well. So this is what happened at the back end. And this is where the technology comes in to ensure that the alert, the notification basically can happen instantly once the customer places their order. So once the driver has been assigned, so this is where the driver will pick up the order from a hub. So definitely hub can be anywhere. And this is where the application must be able to identify which driver is actually closer enough to the hub or the place or the pickup location. And it commences with the last mile delivery journey. And then at the end of the journey, the consumer should receive the gift less than 24 hours. So basically now, as I mentioned, that 84% or around 80% plus, the customer requested the product should be delivered within around 2 hours. So this has become challenging. If you maybe 1, 2, or 3 application, maybe we still can handle. But then if we talk about 10,000 application per day, because in country like Malaysia, for example, like today maybe some of you are celebrating the birthday. Maybe today, some of you, when you are listening to me, you place an order to place, for example, one gift to the parents' house or your beloved ones that you like to surprise them. So you can do like many things at once. So what we are talking now is the back-end technology would happen. Yeah. So this is basically the examples typical of the on-demand delivery. And then in reality, on-demand delivery basically growing, yeah, complex to do constantly changing market dynamics, logistic inefficiency, and so on. All right, so what are the opportunities of job in this one? So we are reaching there. So what I would like to emphasize on my today lecture is about programmers. It's about the software designer. So this is the potential job for us to contribute for this kind of system, because my background is in IT, so definitely the job opportunities is from the IT side. So this is where the capability for us to provide the customer for an application, which is useful application. So can be in the form of website, can be in the form of the mobile apps. Are there, because in the end of the day, when we talk about the front end technology, usually in IT, the system will be appear in 2 ways. So number 1 can be in the form of mobile application, and then number 2 can be in the form of website. And then companies, sometimes they want to go across that. So means that the company provide a system whereby the website is there is also the mobile application version or the mobile app version of it. So That's to respond for Dr. T. Thank you for the question. So now, if we do it in short, then this is how it looks like. So we do the booking online, then after that we assign a driver that he will accept the job. Then after that, the parcel will be collected. Then after that, the parcel delivered at the same day. So imagine if this driver can receive many jobs at the same time, and then the software can help the driver to identify which route that he wants to go, and then they can the system or the artificial intelligence able to direct or able to advise the driver so which location that he can pick up, then after that what will be the next location he can deliver. So it will be like efficiency in terms of cost efficiency from the driver side. So when the driver happy with all the system, definitely customer is happy because they can predict or they can communicate with the driver. They know when they have to be at the pickup location, so they can manage their time on that. Okay. Can you brief front end and back end programmer? Most participant electrical? Yes, I understand. All right. So basically, when we talk about programmers, we talk about the capability for us to create a program. Later on, I show you about the codes about the to become a programmer. Programmer is not necessary to be from IT. So it is very open knowledge and open skill, and then you can have like many tutorials and also many what you call workshop in the YouTube, in the other platform as well. So that basically the front end programmers, so it will focus on the application that will connect the system with the user. Whereby for the back end, it is more focusing on the receiving the demand from the customer. Then after that, how they can manage to communicate, because at the back end, this is where all the department in the company, it will be integrated. So just now I mentioned about just one click away, the customer just what do you call click the button, but it will trigger all the process at the back end. So this is where the warehouse will receive notification. Then after that, how the driver being assigned. Then after that, how the warehouse can calculate whether the safety level for the warehouse, it is there or not, whether they need to place an order to replenish the item and so on. So in the warehouse itself, we have another process, another technology to be in place, so that we have to ensure that enough a product are there when the customer put a request. So basically that's how to differentiate the front end and the back end programmer. So front end is focusing on the communication with the user or the customer, and then back end is focusing on the internal management. All right, so now what will be the solution for that? What will be solution for this? Yeah, when we talk about the bigger version, when we talk about, for example, the shipping company, most welcome, Dr. T. When we talk about the shipping company, when we talk about delivery of services, and then we see it from bigger perspective, then we have a theory, we call it load planning and route optimization. This is what IT people learn about artificial intelligence, and then how artificial intelligence can solve this problem and also can support, can help us in terms of the cost efficiency. So when we talk about artificial intelligence, basically we talk about a program. Program means steps or steps that need to be done for a system to understand what is the input, what is the demand, and then what are the ways for us to achieve the target or to achieve the demand. So basically the algorithm, we talk about the potential solution, so that we can, we want to ensure that whatever customer wants, actually we can fulfill that. So we find ways basically. So in artificial intelligence, the first thing we have to understand about the algorithm or the mechanism or the methodology, yeah, maybe in other words, yeah, it is algorithm. Usually in IT we call it algorithm, but maybe I can translate the algorithm in other terminology. Can be a mechanism, can be a way, can be a method, yeah, for us to make sure that the demand is fulfilled. So now solution for this, when we want to manage, when we want to manage all the services, and then we imagine that we can have like 10,000 requests in one day. And then we talk about Peninsular Malaysia, and then we have not talked about, for example, the Sabah Sarawak side. So in one day we can receive like more than 10,000 requests, and then how we are going to manage that? So this is where we can have what we call as load planning and also route optimization. I'm going to talk this one a little bit more. When we talk about the load planning, we talk about the vehicles and then how the vehicles can carry the product, so that we have to ensure that the position of the product inside this truck is fulfill what we call is LIFO, last in, first out. So we have to place this product in such way that the unloading time must be minimized. So imagine if you have to deliver 10 package to different customer, to 10 different location, then you have to manage your product in such way. You have to arrange your product in such way so that when you arrive to the destination, no need for you to search for the product. The product is already in front. The position of the product is already what they call ready to be unloaded. So this is what we call as the load planning, and it has algorithm to control that. And then so load planning focusing on the how we are going to place the product into the vehicles. When we talk about the route optimization, we talk about from the warehouse, for example. So to which location, for example, as a driver, we receive 10 parcel and we need to deliver the parcel into 10 locations. So we have to decide which location we have to visit first. Then after the first location finished, then what will be the next location? And then what are the possible route? So that we call it constraint that we have to fulfill in the route optimization. And this is where IT people learn about algorithm, about the ways on how to solve the problem. And one of the algorithm we call it, or we have to find out the solution, we call it search algorithm. So today I would like to share with you about that. So now we focus on the first solution, which is load planning. Yeah? As I mentioned just now, load planning focusing on the how to place this product into the vehicles or into the bin, so that when the driver reach one location, then he easily can pick up the product, unload the product. We call it LIFO, last in, first out. So that's the mechanism that we are going to use to place this. And in the route optimization, we are going to talk another algorithm. Yeah, so let me focus for the, let us see the load planning first. All right, so this is the load planning. So now the load planning basically is a process, it's about the capacity optimization. Just say we don't talk about truck, but just say we have a small vehicles. And this is every vehicle, definitely it has capacity. So load planning, basically the process of combining the shipment so that we can use fewer vehicles to deliver goods. So when we are in industry, definitely we have many vehicles, depending on the customer demand. For example, you can have 2 vehicles, 4 vehicles, or 5 vehicles with the different type and different capacity. And this is where you start looking at the optimized way for you to carry the item, then after that delivered to the customer. So if you look into this process, then this will make the trip more efficient and also reduce the transportation costs. So how we are going to learn about that? So in the artificial intelligence, we learn about what we call as bin packing algorithm. And this is how I would like to address as well about the academic and industry gap. Sometimes we receive comments from industry that the students do not understand fully the problem happening in industry. And then the student has been learned about the theory without sufficient practical or sufficient exposure about how to connect the theory with the practical work. And this is, I'm trying to connect the theory that we learn in the class to the practical work. which is we understand that in industry they have this problem about the load planning, and then this is what has been taught in the class, and I'm going to connect both. Yeah, so my what do you call, my aim basically is to motivate the student that what university give you is actually the main idea, but then it's all about the exploration. It's about how you are able to expose yourself with the information in industry, and then you can relate, oh, this is what I have learned in the class, and this is what happened in industry. So basically it has some connection. It just need for you to have extra effort for you to combine what you have learned in the class and what is going on in industry. So as I mentioned, that programming is open knowledge and open skill. You can learn. You are from electrical engineering, for example, it is okay. Once you have understood about what happened in industry, and then you understood how computer can help to automate things and then to make things faster, you can have like solution faster compared to the manual process. And this is the algorithm basically is very logical, is very human minded kind of mechanism, because artificial intelligence basically it mimic the human capability to think for the solution, but then we are going to write a machine using the code so that the machine can mimic or can create like a replica of what human thinking, so that he can solve our problems easily. So basically that's what's going on in IT. So now let us see let us see this problem, yeah, capacity optimization, and then what we see in the class. So in the class, there is one algorithm we learn about, what we call is bin packing algorithm. So basically, bin packing algorithm is for us to find ways how to place an item inside the bin or inside a container, whereby the container has limited capacity. So when we learn in the class, we learn about the items and then having how many you need, different size. Then after that we have the capacity. But then if we relate it with industry, so basically it relate with the load planning, it relate with the solution, it relate with the on-demand delivery services, and this is where the algorithm will tell you there are 5 ways for you to place the item inside this assignment. And these 5 ways, we call it next fit online algorithm. First fit, best fit, first fit decreasing, and best fit decreasing. So usually what we learn in the class is the way for us to understand the algorithm, and then how to write the algorithm, then implement. But then where to implement? So this is where the students sometimes lost. So where to implement? Again, I mentioned that it can be implemented in the load planning. So now let us see how it works. So when you see the items, item have several units. For example, here we have item with the red color, it has 2 units, and then yellow color has 2 units, and also another pink, what do you call, black color 2 units, and then this is the blue color 2 units, and we have one item with the pink color, it has 3 units. And then another one, we have also several items that having single unit only. In the meantime, we have 5 bins capacity. We have 5 bins and with its capacity. And then how we are going to place this item into the inside the bin. So this is where, for examples, we can place all the items which is more than 2 units. We're going to place it first. This is where you find the red color. It is placed at the bottom. Yellow color also at the bottom. Black color at the bottom. Then after that, the pink color at the bottom as well, and also the blue color at the bottom as well. So meaning that human will think that higher capacity will be placed into the bin first. Of course, the bin has its own capacity. We are going to talk about that later. So this is where we are going to place it. After we place all the item inside here, then the next item will be focusing on the single. So this is why we are going to place the single item in such a way so that the 5 bins can have or can accommodate all the items that we have to carry. Whether it is efficient or not, we do not know. So this is where the artificial intelligence will teach the students, whoever learn about artificial intelligence, they are going to learn about the algorithm. This is the way. But then we need to have, because this is 5 algorithms, so we need to have different, what they call, different case study in order to cater the 5 algorithm. So just say with this same analogy, now let us put unit size. So this one is using color and a little bit difficult for us to measure. So we want to using numbers to make sure that the unit is measurable. So now let us see that the bin capacity, and then this is unit size bins. List of item, we have the item, the capacity is 0.7, 0.4, and so on, whereby the maximum volume or the maximum weight that the bin can carry is only 1.0. Just say like that. So now, how many ways for us to place the item? So the first one, artificial intelligence say that we can have what we call is next fit. So what is that? Means that if we receive some data, so this data is actually key in by the customer. So the customer would like to ask the system, what should I do? So this is where customers say, okay, I have bins. Yeah, I have 5 bins. Maximum bin capacity will be 1.0 kilogram, just like that. In the meantime, I have list of this item. So I have the item with the weight, for example, 0.7, 0.4, 0.2, etc. So the algorithm will read this data. So once the algorithm read this data, if the algorithm implement the next fit, then it will read one data, then after that place into the bin. So this is the result. So for example, the algorithm will read 0.7, then it will place the bin number 1. The next one is 0.4. Why 0.4 is not placed inside the bin number 1 is because it is exceeding the capacity. So if exceeding the capacity, then we are going to place into bin number 2. So that's why 0.4 go to bin number 2, and then 0.2 still placed at the bin number 2 is because the capacity is still lesser than 1.0. And with a similar technique, then we can find 0.7 here, 0.6 there, 0.3 can place here, and then 0.2 there and 0.8 there. When we learn about artificial intelligence, we learn that the next fit online algorithm will give us this result. It means we are going to use 5 bin. 5 bin, if we relate with the load planning, means that we need 5 vehicles. So now we start thinking, how can I reduce this? Because 5 vehicles means we talk about the petrol, we talk about the 5 drivers, 5 petrol, 5 routes, and also the timing. So this is when we start thinking another way, how to reshuffle those so that it can reduce number of bin or number of vehicles that we're going to utilize, because it will be more cost efficient. And this is where the artificial intelligence say you can start thinking the first fit. But how artificial AI or artificial intelligence know that can be the first fit is from the human. So we have like some expert, and then they are given this unit site, how they're going to solve the problem. So basically that what we are going to write on the coding, which is later on we are going to see the coding over here. So the first fit, basically, he will place 0.7 there, but then the algorithm will read the entire data. Then after that, we'll find the first fit for this first data. So that's why 0.4 is skipped. So the algorithm will find 0.2 will be placed there. So that will be the first fit for this first bin. And then the secondly, 0.4 will be placed there. Then it will read the entire data. Then after that, you will find 0.3 will be the best fit for this one. And then as a result, with the same analogy, then it will find 0.7, and then they will pair with 0.2, 0.6 do not have any pairing. Then after that, 0.8 do not have any pairing. So in the end of the day, the first fit online algorithm, it will use 5 bins. Still, it's not being optimized. And this is where we look at another alternative algorithm. We call it the best fit. But we need to spend time because the algorithm will read the entire data. You imagine if this is like, this is how many data, 8 data, but then imagine it's like 800,000 items per day. So this is where we need to have computer to have the solution. Fast computer, fast processor in order to solve this problem. They can do computation faster. So this is where the best fit algorithm will read the entire data, then after that start pairing the data so that it can fulfill the maximum capacity. Then you can find out that 0.7 pair with 0.3, 0.4 pairing with 0.6 and so on. In the end of the day, we can reduce the number of vehicles to be used, but rather than using 5, now we can use only 3. Yeah. Okay, so of course, it has correct the 30, it has many trials and all. So this is where the manual process is not the option. So we need to we need to have some automation. We need to have computers in order to find a solution. And then beside the best fit, we have also the first fit decreasing. So this is where the combination is a little bit different. So it is same, it's still used for vehicles, but then the combination is different. So a 0.8 will be placed over here, 0.3 and so on. This one also almost the same thing. But what we can see is that from the 5 algorithm, the 3 algorithm in AI give us the optimum solution, the best solution. So this is where the artificial intelligence can be used as one of the solution for the load optimization. So let me stop sharing because I would like to share my entire screen with you. So now I'm sharing my entire screen. So let me just go here first. Now I would like to bring you to this link. So this slide is actually can be shared, so you can use this slide. And I want you to open this link. Let me just go to the chatting. Then after that, I share with you, so everyone can open this link. So now, from this link, which is you can see from the screen, right? This is where the bin packing algorithm using the same concept. Now we have understood and we have appreciated more about the 5 algorithm, and we understand sometimes for some reason, maybe the first algorithm is the best way. But then for the different case study or different data, we can use the third algorithm can be the best way, something like that. Yeah. So now let us see how the bin packing looks like here, which is the target is actually to minimize number of used bin in the form of coding. Yeah. So in the form of coding, definitely in the coding, we only care with the input. Yeah, what will be the input, what will be the data that we are going to receive, and then we are going to implement the algorithm in order to come up with the output. So for example, the input can be in the form of weight, and this is where list of items that we have, that we just said this is the parcel that we need to deliver on that day, and then we have the bin capacity, or we have the vehicle capacity, which is maximum 10, and then the output, the system will suggest you need 2 vehicles to carry all this load. And then using the algorithm, the system able to advise you that the first vehicle or the first bin will contain, for example, this is this item 442. If we have index or we have the ID for each parcel that we have, so we can suggest that the first vehicle will carry the first parcel, then after that the 4th parcel, and also the 5th parcel, whereby the rest it will be carried by the 2nd vehicle. So the system able to come out with a suggestion, and it will be very fast. So when I mentioned just now investing the time, computer works with millisecond. So 1 minute is already long in the computational method. So it's already long. So we talk about millisecond. So if we can solve the problem within 5 milliseconds, then it's still satisfactory. It's still sufficient enough. I mean, it's quite. I mean, the speed is sufficient. Yeah. For the system to provide the solution. For example, here we have different weight and also the capacity. For example, is 10. The system will update you that you need minimum 4 bins to accommodate all items. So this is where, for example, in the Monday morning, and then we understand how many parcels we have to deliver in that day. Then the management of the company, they know they have to come out with the 4 vehicles on that day, because the system already advised you to use the 4 vehicles. Yeah, for example, we have a different type of data. Then after that, the bin capacity is 10 or the load capacity is 10 for the vehicles. Then only 3 vehicles will go there. Yeah, and then we can have some lower bound. I think you can read by yourself for this one. Yeah, we can have a lower bound. I mean, like what will be the minimum, what will be the maximum, the upper point. Yeah, and then in terms of application, so you can see that the bin packing problem actually can solve some problem in industry. For example, in loading containers like truck, placing data on multiple disks, or job scheduling, or packing advertisement, yeah, in fixed length radio or TV, and storing large collection music or etc. Yeah. And then this is all the algorithm that I have mentioned to you just now. And this is how you can obtain the code. This is, I mentioned that the code is actually open source. It's not necessary for you to be a computer science to learn about the coding. So this is the coding written in the 5 different what we call languages. For example, you know about C++. And you know about C++, you can write the coding. So this is basically the code, and that's what will be the output. And this is how it looks like the code in Java, and also Python nowadays are gaining attention. So this is where the code in Python, and also we have C# and also we have JavaScript. So it is possible for you to learn about this one. And also whatever algorithm that I mentioned to you is actually available online in many languages, in many programming languages. So this is, for example, the best fit. This is the worst fit. And then we talk about the offline algorithm, first fit decreasing, and so on. So we have a lot of algorithm in artificial intelligence that can solve industry problem, which is coming from the bin packing algorithm. So that will be the first link. The second link, I would like to bring you to this one. Let me just copy the link. And then let me go to chatting to share with you. So now let me open the coding. I mean the link. So now, now you are exposed with what we call is Google or art tools. Maybe you have heard about Jupyter Notebook, or maybe you have heard about Google Colab. So basically, Google Colab is the online programming tools, so that if you do not have Python on your machine, you can copy the code that you found, or you want to trial the code that you found into the Google Colab. They want using Python. So using Google Colab using Python, so that you can run the code on the cloud on the Google website. And then what I brought to you, what I bring to you now is one of the tool which is provided by Google. They call it Google OR tool, or Google what they call optimization. Yeah, Google for optimization or for operational research. And this is where you can see that this Google OR tool is basically have the function to do the optimization. And this is the bin packing. So I just purposely go to the bin packing link. So in here, you can learn about Python, C++, Java, and also C#, but then they will use function that has been developed earlier by Google. So no need for you to create coding from scratch. Yeah, the difference is that when I brought you into this website, this website is telling you how to become a programmers using different programming languages, and then you do just everything from scratch. You create your own function, then after that you're going to utilize your function. In the Google OR tools, Google already developed for you, but you have to know what are the function available, and then how to utilize that function into your coding. So no need for you to do everything from scratch. So this is why the first line on the Google OR tools is actually here, from OR tools, linear solver, import, py, which is for Python, py-rep lp. So by using this function, you can utilize into your coding here. So you can call the function for you to come up with the a solution for the bin packing algorithm. Yeah. So beside the bin pack algorithm, actually we have the knapsack problem as well. So this is the knapsack problem, whereby we want to place the item inside the box, but knapsack is more simple compared to the bin packing problem. And also we have multiple knapsack. For example, here, this is where multiple knapsack as well. So we can have the code. Then after that, this is where the code will suggest us. For example, we want to know, yeah, what will be the output. So this is where we can run the program. Then after that, we can find out the total pack value is this, and this one can be placed inside bin number 0. And this is what are the items, what is the weight, what is the value. The value can be the cost or can be your profit. And this is the pack bin weight. And this is for the bin number 0. Bin number 0 can be vehicle number 0. And this is the bin number 1, bin number 2, bin number 3. So we can come up with this suggestion by using the algorithm. And you just need to key in the data. So once you key in the data, then after that, the data will read by the system, then the system will process using algorithm, then come up with a suggestion. So now when we have demand that the input, the data input into the system, we want it to be in the fast way. This is where it has technology, or it can be transformed. The input can be read from the QR code. The input can be read from the sensor. This is where IoT coming in. Yeah? So we welcome IoT as well to understand the things there. Okay, the tools help to create solution. How about the formulation understanding? Should we know exactly the solver? Yes. So when you know how to calculate, or I mean mathematics and statistic knowledge somehow becoming the key of the solution. Because for example, later on I'm going to show you about the current research, which is in the 3 dimension. What we are learning now is only 2 dimension, but actually the requirement in industry, they require to have 3 dimension of the item, yeah, not only a 2 dimension. We are going to come in that later. And then in that we have a linear programming. Yes, this principle can be applied definitely. So later on, I'm going to show you one of the data mining process, whereby data mining process will utilize the clustering technique, which is k-means clustering, to solve the route optimization. Yes, we can accommodate so many calculations. This is where you can come up with your own algorithm. You can customize your own algorithm with all the formula that you have learned in the mathematics, in the statistics, in other subject as well. So the program basically is like a platform for you to place any formula so that you can achieve your goal. Basically, it's like that. Okay, so this is the two, two links that I introduced to you so that you can explore more. Then you can have your own experiment in the coding. Basically, what you are doing is to find solution for the load optimization. Let me stop my sharing so that I can go back to my slide. All right, so now I come back to my slide. So let me just enlarge this. So basically just now, what we have seen is one solution using bin packing algorithm, how to place the order. The next one, I would like to show you how to handle the data, which is like big data. But this is like still small data. 366 is a small data, but maybe very close enough to the reality. So just say today we have to deliver 366 data set of the item size. And then the data, just now in here, the data is very general. So now let us closer to the real world. In the real world, you may have some description, the properties of the product that you want to carry. So this is where you can have data about the actual weight of the product, and then the actual from you guys?
Yeah, connection issue, I think.
Oh, okay, all right.
Yeah,
So
I lost, I think, nearly a minute of the connection.
Oh, okay.
Are you okay? Most resume already. Okay.
Oh, okay.
I didn't know
all
what
right.
happened. Could it be
Okay,
the
no
net?
problem, doctor.
Let's listen. Your lecture is attracting me already. I'm posting a lot of questions. I'm your student now.
Dr. T, come on.
It's interesting actually. Yeah.
Thank you. Thank you for the encouraging words. Okay, so just now I mentioned about the data set item. We talk about big data. We talk about the item properties that is very close enough to the real one. So we have weight, we have.
Do you want to post the slide on screen?
Oh, I have not posted the slide, is it?
Yeah, because possibly just now is disconnected.
Oh, okay.
You need to repost
Okay,
it.
sorry for that. Okay, let me just try to. Okay, is the slide available now?
Yes, no. You want to
Okay,
put it
that's
into full screen or?
I will.
Okay.
All right. So this is what I'm talking just now about the data or the big data, and then we want it to be closer enough to the real world. And this is where sometimes you receive the properties of the data. So we can have some description about the data. We talk about the weight, the height, and also the actual length. And the first thing the program have to do is to calculate the volume. So based on this volume, we are going to place this item inside our vehicles. So for example, here, definitely what they call the volume requires formula. And this is the mathematical formula comes to place. And then you're going to put it as a program. Then you're going to have some looping so that all the 366 item can be calculated within like less than 1 minute. So we can have all the volume there. So after the volume, we find out now we need to have some algorithm, and then the algorithm that suggested to what they call to be used is the Google or R algorithm, which is I have shown you just now. So now I would like to stop sharing a while because I want to share the whole screen because I want to. Okay, are you able to see my screen now?
Yeah. Can
okay,
I can see.
great.
Others student can see.
Yeah. So now I would like to share this what do you call? So I would like to share the third link for you, which is coming from the lorry. If you have heard about the lorry Malaysia, so this is their backend process. So now let us open this website. So this website is from supported by the lorry Malaysia, and it is about the load optimization problem. So the data actually I took from here. So similarly, so the author has been talking about the knapsack problem and also bin packing problem and also the OR tools Google library. And this is where the coding, so just now I have told you about this problem that we have the volume, then after that we have the actual weight, the width and actual height of the what they call of the data, and this is how we are going to code that. So in Python, because this one is written in Python, we have what we call as pandas. Pandas means the data is placed in the form of table. So we want the program to be able to read the data in the form of table. So this is why we need to import one of the tool, which is pandas, to save the database. And then we have to follow the format accordingly based on the Python that it must be at the CSV files. Then after that, we call it as data set. Then after that, we are going to have some instruction or some command in Python language. And this is where we can display all the data set. For example, at the moment, we have 367 rows times 4 columns. So this data consists of the width, the width, the height, and also the length for each item. So basically, we want to handle 367 items in this example. So now after we have all those, this is why I mentioned just now we have to get the volume. And this is where all the mathematical formula comes in here to calculate the volume. And this is where the volume becoming the result of this coding. Then after that, so the result, after we got all the volume, so we can know the total volume is this much, and also the total weight for the 366 items just now is around 9,853.69 kilogram. So the total volume is around 46 million centimeter. Yeah, and the total weight is around 9-point-something kilogram. So the problem is that we want to know how many vehicles should be used. So after the data ready, then this is where defining we are going to define the number of vehicles that we have into the coding, and this is where we start recording, or we start putting the data. So just now we have got the data about the item that we need to deliver, and this is where we key in the data about the vehicles that we have. So for example, we have lorries, and this is the code, the description, it is a pickup, and then we key in the properties of the vehicle. So for example, we have length, height, width, and maximum weight that can be carried by this lorry is around 500. And then number two, we have another vehicle, which is van. So for example, van, we have the length, the height, the width, and also maximum weight is 500. And then we have lorry S, maximum weight will be 1,000, for example. Then we have lorry M, maximum weight will be 3,000 kilogram. We have lorry L, maximum weight will be 5,000. Just that this is the vehicle that we have. Yeah. And this is all the lorries, we key in the data, and this is the result for all the lorries. Then after that, we want to define the main process using the OR tools. So basically this is the code. So I don't explain too much because because it's restricted with the timing. Yeah. But basically I give you the link so that you can study more about this coding. Then after that, we do some algorithm there. So we need to import the OR tools library. Then we define the function, yeah, the maximum volume, maximum weight. Then after that, we want to get the load optimization. Yeah, so this is all the data that we have key in. Then after that, based on the total lorries variable, we have one lorry L with maximum weight of 5,000 kg. This is the maximum volume. Also, we have two lorry M and so on. So total vehicles are 15 available, just like that. So meaning that for this industry or for this company, they have one lorry L, and then they have two lorry M, they have three lorry S, they have three van, and also six capacity of the vehicles. The total vehicles are 15. Now we start using the OR tools library, which is provided by the Google, to optimize our data. And this is where we put the function, yeah, which is available inside our tools library. Then after that, we put the codes there. So in this coding, this is all the explanation. Yeah, and then the following code will only execute if the status of the optimization processing has a true value to show the result. Yeah, so I just skip this one, and then this is the result of the system. So the result of the system telling that the total lorry, so this is the total lorry that we can utilize. And then the total item will be 367 items that can be carried by using this lorry. So we can, the system able to come up with a suggestion, for example, for truck number 0, and this is all the properties of the truck. This truck will carry item number 0, number 7, number 9, number 12, all item that we have listed just now, 366 items with all the weight and the volume, it will be assigned to truck number 0. So it's not human work. It is like AI work. AI will find for you which item will go to which lorry. So this is truck number 1. We still have truck number 0. We still have truck number 1. due to the capacity, so the truck number 1, due to capacity of the truck and also the weight and the volume for the items, then the system will suggest, I will suggest item number 6, number 8, number 10, number 11, and so on. This one will be assigned to truck number 1. And this is the truck volume, this is the truck weight, and we still can calculate the left volume and lift weight. So meaning that if you want to assign another product which is not belong to the 366 item, we can place there. Basically, it's like that. And this is how we assign track number 2. So the AI will assign item number 13, number 21, number 22, and so on until finish for track number 2. And this is track number 3. And this is track number 4. This is track number 5. This is track number 6, which is van. So van can carry this much with the this weight. Yeah. Then after track number 7 is van again. And track number 8 is also van. Track number 9 is lorry S. And this is the item we are going to place inside lorry S. And this is for lorry 10. We have 15. Yeah? So this is truck number 11, which is lorry S. This is truck number 12, lorry M. And this is truck number 13, which is lorry M. 13, and this is truck number 14, which is lorry L. So that you can see that this is how AI, it is 14 because we start just now from truck number 0. So basically all the 15 vehicles has been assigned, and then the AI algorithm find the item, which item to be placed at the truck number 13. So it will be easy, so that the human just carry what they call the type of the product, then after that place into which vehicle. So this is one of the solution that AI can do. The result could be posted to a UI for end users such as cargo assistant. Yes, correct, Dr. Lee. You are absolutely correct. So this is where when the data, we can handle the data, we can manage the data. Basically, we can communicate whatever we have into the customer. So what we see and the customer see, it will be the same thing. So it is transparent. And this is why the system or the AI unable to bridge the gap between the company and the customer to gain more trust level from them. If it is more trust level, definitely more profit, more transaction, more product to deliver. And this is where the scalability, somehow the algorithm also tackle the scalability. So when we have like 100 vehicles, we still can use the same algorithm. Yeah. So basically that's how AI can help us, and AI can manage the things there. All right, so that's about the load optimization problem using the OR tools, Google Library. So now talking about the current research, what I have shown you is actually the 2D, two dimension of the load optimization. So we only care for the what we call the volume of the product to be placed into the vehicle. But then to make it closer to the real life, actually the product, it has the shape, it has different shape. It cannot be only box, yeah. It can only in the form of a cylinder like this, or maybe in the form of different things. So this is where the current research now to come up with the 3D load optimization and visualization. So for example, if we have the container, then after that we have like different shape of product, how we are going to arrange. So this one can only possible if we do it in the 3D. So this is where 3D comes to place for the load optimization, and also we need to visualize the 3D load optimization, because basically when we have a volume, just now what we care is only the volume, means that we do not care the shape of the product, but the actual one, customer can come up with a box, can come up with a cylinder, can come up with a triangle, whatever product it is possible. Okay, so this is where we want it to be like what we call closer to the real life, the real problem. So this is where the 3D load optimization comes to play. Okay. All right, so that's about the load optimization. The next one about the route optimization. So just say we are able to place the product into the vehicles. Now, how we are going to optimize the route? So where the driver should go, and then how to place the product inside the vehicle so that we can minimize the unload time. When we unload or unpack the product from the vehicles, so no need for the driver to look for the product, where is it? And then is it customer number one, where I place the product, so no need to have such problem. So the route optimization basically is the process to determine the shortest possible route to reach the location. And this methodology has gained popularity in the transport and logistics industry. And since it reduced the time span of traveling and also reduce the what you call at the same time reduce incurred cost in the process. So that's why route optimization becoming a very for IT, this is like a very hot research item for us. And then before company or organization can employ this strategy, it must first be able to document all for its business route, and then after which the expert can use the provided data to predict the best possible route. So what you see over here is, for example, the route plan optimization on the left side and on the right side. So on the left side, this is where the case study, we are referring to the warehouse. So means that the pickup location and also the ending process, yeah. The pickup, then after that delivery, then after that the driver come back to the base station. So it happened like this. So this is like the headquarter or the warehouse, and this is where the driver need to deliver the package to the different location. Then after that come back to the warehouse. And then in one day, we can have like 300, 500, 1,000 parcel to deliver. This is where we start come out with the route plan. But then the route planning, we have to fulfill some constraints. So for example, we want it to be minimized. We want the driver to be, for example, some area are very high traffic. So means we want to consider the timing as well, because customer is waiting. So this is where we can reduce the number of the location that the driver need to deliver in the congested traffic jam in a certain location. So we can come up with many strategy. So this is where after we do the planning, when we do the optimization, we can come up with the different route for each driver. So instead of, for example, this driver visiting many locations, maybe this is a very traffic jam, very congested location. This is where we reduce, and then the driver just need to deliver this location only, whereby the other driver can cover this location, the other driver can cover the location, and so on. So depending on what do we want to achieve, so the algorithm will follow, then after that come up with a different route plan, and this will optimize. It will find the best solution for the drivers and also to make costs more effective. When we talk about the route optimization, there is one terminology, we call it VRP, or vehicle routing problem. So this is where we want to reduce the traveling time, and also we want to maximize the capacity use, so that reducing the traveling time definitely will make customer happy. And also this is the vehicle whereby we want the profit to be as much as possible, and so on. And this is the current trend in the research is, we call it vehicle routing problem. So you can Google about that. So whenever there is discussion about VRP, actually in the university, or maybe you have heard before in IT or in artificial intelligence class, the vehicle routing problem, it was originally known as a traveling salesman problem, or we call it TSP. So this is a very classical problem, and this is the genesis of the first version of the vehicle routing problem. Traveling salesman problem, they have only one vehicle and one salesman, but then the salesman need to visit all the city location, all the city, all the location before he come back to the warehouse. Whereby for the vehicle routing problem, we're talking about many vehicles. A traveling salesman is only have one vehicle. Okay, so this is why in the current research, especially in 2022, if you want to look for solution for the route optimization, you can find out from the keyword vehicle routing problem. Yeah. So over time, the business strategy evolved. The travel salesman problem interpreted as vehicle routing problem, which is becoming more complex, which is firstly, the vehicle routing problem published by George Danzig and John Ramsey in 1959. Now, vehicle routing problem having a variety of what do you call a problem that they want to tackle. Again, that the idea is that to make sure that the customer happy or customer can place a certain constraint, and then the shipping company able to fulfill the customer demand. So the three complex problem in the vehicle routing, yeah. For example, we talk about vehicle routing problem or VRP with the pickup and delivery point. So when we talk about pickup and delivery point, pickup and delivery will solve the capacity of the vehicle, because the vehicle will be full with the item, yeah, and the capacity will resume when the item is being delivered. So for example, they have like the driver from the warehouse carry like the 10 items. Then after that, it is delivered 3 items on the way before it pick up to the next item. So pick up delivery, basically it solves the solution in terms of cost efficiency, also increasing the profit. If we want to compare with this one, with this, the vehicle having full item at the warehouse, but after the traveling, it carries nothing. Can you imagine that? So after the delivery, they have all the profit, we have all the transaction, we finish the transaction, we come back. But on the way back, actually the vehicles is empty. So this is where the vehicle routing problem try to make sure that in terms of profit, on the way back, when the driver on the way back to the warehouse, it still can have some delivery process. So this is where they introduce the pickup and delivery, VRP with the pickup and delivery. So in this case, more similar with general overview route optimization, certain goods are identified with the need to be delivered from a pickup location. The aim of algorithm in this case is to find the shortest possible route for vehicle to shuttle the pickup and delivery location. And to fulfill the idea is that as much as possible, the vehicle is never empty before it reaches the warehouse. So as much as possible, so we can increase the profit. Another one is about VRP problem with the time windows. Time windows means that in this scenario, the time frame to deliver is becoming the main consideration. For instance, logistic company promise 24 hours, yeah, delivery after an order will devise its algorithm to solve how the goods can get to destination within the time frame. So this is, you can see this is the mobile app, and then the driver will receive instruction that you need to deliver this item is in about 11:03 in the morning. So the driver, once they go out to carry the item, they have received several suggesting points which is come out from the artificial intelligence algorithm. And also, as I mentioned just now, we have a vehicle routing problem with the LIFO. LIFO means last in, first out. So this one is focusing on the algorithm that focus where to place the item inside the vehicle. So vehicle must be loaded with certain amount of goods at any delivery location. To achieve this, the item to be delivered will be the one that was just added to the truck. The time spent unloading is aimed to reduce since only the recent ones are to be dropped off. So this is the LIFO. So this is the challenge that currently happening in the industry, and we want to be free from the manual process. So this is where we would like to using the code into the computer, so that computer can process faster and can handle big data in a very fast way, so that it will ease the manual process or human in this view. So this is where artificial intelligence can help cost efficient, yeah, in this industry. Okay, so I want to show you some codes. So now let us go to the Google OR tools. I believe you're still able to see my screen. So now let me just place this what you call this link to you, and let us open this together. Yeah, we just see. So this is the Google OR tool specifically for the vehicle routing problem. Yeah, so we can see on the left side, we can have like overview. Yeah, so this is the overview. One of the common optimization tasks is vehicle routing. Yeah, in which the goal is to find the best route. Yeah, of the fleet of vehicles visiting a set of location, and usually best means route with the least total distance or cost. And here are a few examples of the routing problem. For example, package delivery company wants to assign routes for the drivers to make deliveries, or as cable TV company wants to assign routes for technician to make residential service calls, or a ride-sharing company want to assign route for the drivers to pick up and drop off passengers. So as I mentioned just now, the famous routing problem is DSP, or traveling salesman problem. And this is where, for example, we have the graph. Then after that, we have some location labeled with the A, B, C, D. And then it has also some distance. And this is where the distance, any two location is given by the, what you call, by the numbering here. Yeah. Means that reflecting the distance. Then after that, we can calculate the distance for all possible routes. For example, the shortest route we find out is ACDBA. So means from A, go to C, go to D, go to B, and go to A. And then the cost for the distance is actually 90. So now the problem gets harder when there are more locations. In the example above, there are just 6, but now just say the point routes is around 10 location. So if it is 10 location, then the possible number of route using combinatory calculation, then it can come out around 362,000 plus. For 20 location, the number of jumps, yeah, the number jumps to this much. So definitely this is exhaustive search. This is where for the larger problem, optimization technique are needed, yeah, to intelligently search the solution space. And this is where what you call the algorithm for the vehicle routing is introduced. So for example, first we want to see the solution here in terms of coding. This is the traveling salesman problem. We try to start from a TSP because TSP have smaller version of the traveling. So they have only one driver and also one vehicle. Yeah. So this is the TSP. So now how the coding looks like. First, what the coding needed is actually the input data. So this is where the data can be in the form of matrix. So this is the distance matrix. Yeah. So this is the distance metric. We recorded all, and then number of vehicles will be 1. Then after that, depot is 0. So this is the explanation. The distance metric is array, yeah, from one location to another location. Okay, 20 minutes left. Okay, thank you. Then after that, this is all the what we call the city, which is based in the US. And then after that, the data also include number of vehicle, which is 1 because it is on the TSP, and also the depot. The depot will be the start and end location of the route. So in this case, the depot is 0, which is correspond to New York. Okay, so now how to create the routing model? Firstly, we have to create the routing model. As I mentioned over here, we use Google OR tool. So means that we just need to what they call, we just need to utilize the function which is already created by Google OR tools. So this is where we use the what they call the function. Yeah. So after using the function, then we use the callback. That on you can try the coding. Then after that, we set some parameters and we are going to print the solution. And this is where the solution is. So because we have only one vehicle and also one driver, solution is only 1. So the route for vehicle 0, it will be You start from 0, go to 7, go to 2, go to 3, and so on until finish. Then you go back to 0, and then the miles or the distance that has been visited is around 7,000 miles. Yeah. Now, in the different ways, the route also can be saved in the form of program, and this is how the programs looks like. So this is for the TSP. So now let us go to the vehicle routing problem. The difference is that for the VRP, this is for multiple vehicles visiting a set of location. So this is where the program, definitely it will be what we call different. Yeah, it will be more complex. So for example, here is the graph here with all the location, but then we have many vehicles to deliver the package. So now how to solve the VRP example with the OR tool. So we create the data, and this is where we create all the distance metric data. Then after that, the data consists of this distance of metric, number location, then after that number of vehicles, and also the depot. And the index of depot, the location where all vehicles start and end their route. And also we need to have location coordinate. So this is all the coordinate. In the real life, this coordinate actually the longitude and the altitude. Yeah. So this is the coordinate. Then after that, we start using Manhattan distance. I believe you guys have learned about Manhattan distance. Then after that, we do some callback and then distance dimension. So, and then this is where we will print the solution. So because we have multiple vehicles, so the solution can be, this is the route for vehicle number 0. Because we have make assumption that the load optimization has been solved. And this is where we're focusing on the route. So if, for example, we have 4 vehicles, then this is the route vehicle number 0. And this is the distance. Route vehicle number 1, this is the route, and this is the distance, and so on. Provided that the load optimization has been fulfilled. And this is how the route looks like, yeah, using vehicle routing problem. Now, the next one can be in the form of constraint. So let me just, this one you can click by yourself. Yeah, means that you can explore by yourself, but let me just explain 2 or 3 with the timing. For example, we have capacity constraint. If we have capacity constraint, means that in the coding, we would like to place that our vehicles having capacity. Yeah, so using all the coding, and this is where we put the capacity. And the suggestion, because we put some restriction or we put some constraint, you can see that the suggestion will come out in this way. So the objective, for example, 6,000 plus, and this is the route for vehicle number 0, and it will calculate the load of the route. Yeah, so it means that the load, for example, from 0 go to 4, the load is 0. From 4 to 3, from 4 location go to 3, the load is 4. Then after that, go to number 1, the load is 6. Go to number 7, load is 7, and go back to number 0, the load will be 15. So this is the load of the route is 15. Yeah, can be the cost, can be anything that we can place into this algorithm. So it means that the algorithm come up with different suggestions with more detailed data. Just say if we want to add more constraint with the pickup and deliveries. So this is where the route can be different, because it's about the pickup, where to pick up, then after that where to deliver, something like that. And this is where we create the data, the pickup delivery data. Then after that, the request. Then after that, we run the program, and this is how it looks like. So means that when we run the programs, the driver will just follow. This is the route where to pick up. Then after that, where to deliver, pick up again, deliver again, and so on. So this is the route for vehicle number 0, number 1, number 2, number 3, and so on. And this is how it looks like when we do a pickup and delivery constraint. Next one is time windows constraint. So in the time windows constraint, we want to place at what time actually customer would like to receive the package. So this is another constraint that we introduce into the coding. So we use the time windows, all this is all the default. And this is we use the callback. Then after that, we use the windows constraint, and the output is in this way. For example, the output, route for vehicle number 0, yeah, this is the time 2.3. Let's go to pickup location number 14. This is the time 7.8, and so on. So it means that depending on the concern that we want to fulfill, then we just write the coding accordingly. Then after that, we receive the input, the data that we would like to require. For example, the customer with the timing they want to receive the parcel. Then after that, we do the optimization, and the program will come up with a suggestion. So this is where the location that you need to fulfill. And then we can have windows and array as well. And yeah, so basically that's the coding, I mean the complete coding. Okay, so let me continue from here. I still have 2 slides to go. So the next one is to introduce the machine learning. So how we introduce the machine learning into this? The machine learning, one of the techniques in the machine learning is to do clustering algorithm. But what we want clustering algorithm, we only focus on the location for the customer. So which when the location of the customer is close to each other, then that will be the route that the vehicle will go. So the main concern here is to have like one objective, so that the driver do not need to go to the further what they call direction. So it just go for the that particular direction. So I will introduce you another link. Yeah. So let me just copy this link here. So now we can open the link together. Okay. So I will open the link here. This is the clustering algorithm with geolocation data. What you call employing data science algorithm, which is machine learning. So the clustering basically to separate population or data point into various categories. Data point are closer to the other data point in the same category and distinct from data point in other category. So basically based on this one, then what they call, we are going to cluster the location of the customer. Now, what is geolocation? Geolocation means that we want to identify the clustering based on the map. For example, map of KL, map of Malacca, map of Johor, and we want to cluster the location of the customer based on their geolocation. Yeah? So we want to utilize the Google, what they call Google a map, yeah, in this application. And then what type of problem clustering can be solved? So this is actually effective machine learning technique. Yeah, it uses k-means clustering. So k-means clustering can solve many problems, not only for the route optimization. It can also k-means clustering can solve spam filter, classify network traffic, identify fraudulent criminal activity. In terms of marketing, it can solve, characterize, and discover customer segment. In biology, can be used for classification among species of plants or animal. And then for the insurance company, to acknowledge the customer, their policy, and identify the frauds. Yeah? So many things actually can be implemented. Now, what we are focusing over here is just clustering for the geolocation data. So when it comes to the geolocation data, the method that we use is to collect the raw data. Then after that, we use the geocode of customer geolocation data to perform clustering algorithm. So we do clustering algorithm using k-means clustering, and we can cluster the data. So when we implement Google Geocoding API, so this is a little bit like a little bit higher programming level, but it can be studied. So here we use API. API means application programming interface provided by the Google. Then after that, because we want to utilize the Google Map. Yeah? So then we write some coding and also Google Map using latitude and longitude. So this is all, we collect all the latitude longitude data. Then after that, we implement the k-means algorithm. So, and then also we import all the libraries required by the Python. And this is all the longitude data, and this is we come up with a cluster. So this cluster means that driver number 0 will visit 28 location. Driver number 1 will visit 21 location based on the geolocation data. So there are like system cluster in which each cluster have each members. Then after that, we have assumption that each cluster represent one driver who should deliver 30 parcel. So you can see over here some cluster has parcel more than 30. So this is some other cluster only has below 30. So this is based on the geolocation. Now, if we put the concern problem, for example, we want the driver only to deliver not more than 28 items, then we can place some constraint in the coding. So this is where we can find out that driver number 0 will will visit 28 location, and only certain drivers will visit more than 28 location, which is driver number 3. So we can optimize that. And then we can visualize. So when we visualize the we visualize the map. So this is where the driver number 1 will only focus delivered a parcel in this location. Deliver, driver number 10, for example, only deliver package at this one. Yeah. So means that the optimization has been, the route has been created based on the geolocation data. We do not see the distance. In terms of optimization or in terms of profit, maybe it will be more profit if one driver over here, will visit another package over there because it's more profit, for example, in that way. But we do not use that constraint. So when we implement data mining, we can focus for the driver to deliver only for this part, only for this location, only this location. But in order for us to implement this, we have to utilize machine learning algorithm. Okay, so that will be the end of my presentation for today. And I thank you for the opportunity. Sorry for taking too much time. Thank you.
Thank you very much, Dr. Deshinta. This is my first time that I listen to the optimization problems, right, that link into the IT solutions. A good lecture for me, and this is eye-opening for me. I think this is also an eye-opening lecture to all of the participants as well, because I think we have optimizations as a mathematics courses. But not much. I don't think we introduce optimizations as an application itself in the combination of IT and solutions, right? And applications such as this load and route optimization. We combine all the technology with the Google tools, right? No, I don't think we introduce in our faculty. Probably the science, computers, engineering. Yes, probably. I'm not too sure actually, but this sounds like an opportunity for us to integrate with other principles. Okay, thank you very much. I think that is the end of the sharing. I hope we keep contact and then we are able to collaborate furthermore. Before we end, right? Before we end, I invite all the participants to take a group photo. Is it possible to take a group photos? Can you switch on your cameras? Guys, please switch on your camera. Yes, mine as well. Yes. How to switch?
Hello, nice to meet you all.
Group. We're young face, all the faces, right?
We are the most senior one, the 30.
Yeah, let's see how to take the gallery looks okay. The gallery looks right. Camera on, please. Camera on, right? I'm taking your snap your groups, right? Cameras, yes. Look serious. Okay. Hold on. Let me do it again. I don't think I took it. Oh, yes, it's good. Right. Let me took another one. Keep still. Let me do another one. Camera on, please. Camera on. The page number 2. Alright, some of you macam baru bangun daripada tidur je. Betul ke bangun daripada tidur?
Hopefully my lecture do not make them sleepy.
But I think for those interested, right, they will keep awake. Right? I think it's very normal. Right? I've seen my students dozing in front of me when I was lecturing as well. Probably, yeah, probably they don't think it's necessary. Right? But I'm doing the research, right? I think the content and the technology actually interested me. There are more, right? I don't take them, right? I didn't take all, right? So I think I have snapped enough of the photos, and we have seen Akila, we have seen Arif, Iskandar, Bawinam, right? Bawin, right? How are you? Smile, big smile, right? Okay, I seen Wan Wichi, I seen Wichi, I seen Eric Tio, and we see Farina and Arif Aiman, right? Abdul Malik, okay, nice to see you guys, and Uzai, okay. So thank you very much for attending this lecture series. Let's give a big thanks, right? You can type it or you can sound it, you can voice out. Thanks, Dr. Deshinta, for willing to share the content. Thank you very much. Thank you. Okay. Okay. I'll see you guys next week, right? Next week we have another section. We should meet Dr. Azun, right? So thank you, Dr. Deshinta. We should end this session now. Thank you very much. See you. Bye-bye.
Thank you. See you.
Bye.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay, see you.
Thank you, Doctor.
Thank you,
Please
Doctor.
fill in your attendance. Fill in your attendance. Malik, have you seen fill in your attendance? Ada Malik? Hi.
Yes, I already have.
Yeah, the attendance, please fill in.
I already did it.
That's it for today. See you guys. Stay safe, stay healthy.
Thank you so much.